And I'll just show the program now.
XNA is a graphics library?
It's somewhat of a graphics library, yeah. It basically just implements a lot of the code and it provides a lot of new tools.
Where does it come from?
We got it just looked online and
It's like a gaming library.
It's for the Xbox, right?
Yes.
yeah.
It's Microsoft.
Yes.
Yes.
Okay, so here is our actual model. And like I said, we can speed it up by hitting F. And if we could make it like this, we can show where the electron cloud is. You can tell where it's mainly grouping near the center, where it's supposed to do the probability code, but it does every now and then go out. If I slow it down here, I can show some of the other. Zoom in, zoom out. About that close without it making disappear. About that far away, I think you can still see it. I'll bring it back up. Okay, and then what I was talking about with the D key, I'm going to make that go like that. And you can see how it speeds up and slows down. But this will make it, by hitting Shift D, I can make it stay on one plane like that. And eventually it will change. If I let it run for like an hour, it probably would go all the way around. But it's not going to change past 0.5 an angle.
For our purposes, it's staying on one plane.
Okay, and then if I were to maximize the D, you can see where it will go pretty much everywhere. Oh, and something we discovered, if you just saw the electron just pass through the proton. And with the probability curve, in fact, it can actually reach 0. So it can actually pass through the proton, which is something new to us.
We thought that was very cool.
And it's pretty much there. And if I just speed it up again, this basically shows our quantum model. I'm going to zoom out probably a little bit. So I have your program there. And that pretty much wraps it up.
Did your dad show it to his class?
He hasn't yet, but he wants to.
Have you showed it to people around your school?
Not around our school in particular, but I have shown it one to my little sister. She's just learning about this, and
I'm wondering if people look at it and say, "Wow, that's neat."
We've shown it to our friends, and they like it. Yes. But,
I like it, but I'm nerdy, so.
Well, our friends are pretty nerdy, too.
I had a question about the controls.
Yes.
It seemed like, well, I don't know, for a fifth grader or higher, it's probably enough controls for them to memorize and so on, but any younger than that, it might be more difficult.
well, something that we can actually implement into this, which is really cool with the XNA code, you can actually implement an Xbox controller. And I don't really know anyone below 5th grade who does not know how to use an Xbox controller. I'm pretty sure everyone knows by this day and age. And so technically we can implement all these controls to one of those. We just decided not to be.
The controls are also really fun to play with, and we think that, makes it a better educational tool.
What kind of issues did you guys run into with merging XNA and your C# code and getting it to bind together?
Well,
What was the learning curve from learning XNA?
well, I mean, I had programmed a little bit in C# before, and so had she.
Yeah.
And,
Very basic, but
pretty much the XNA, there's a lot more to the graphics. Like, I had never worked with matrices before, and learning the matrix rotation, like the rotation matrix, was particularly difficult for me.
we feel like we really learned a lot this year.
Did you understand, or did you see errors? And you saw
Yes,
errors?
definitely saw errors. We had a couple times where one of the electron would just disappear after a while, which obviously makes no sense. Another one, it never even showed up. And another one, it would rotate on a certain angle and then suddenly change. There was no point for it to do that. And again, it would disappear after a long time. So we definitely ran into issues where it would not rotate in the right directions.
Why it disappeared?
That's because we actually had an error that made it go to 0, or made matrices go to 0, so it would basically just stay in the center of the proton. And so we'd never see it, although it technically was there. And we discovered that when we zoomed in all the way and crossed halfway past the front clipping plane. We saw the electron in the center of that. And that's what happened there. But
So, are there any plans to extend this to helium?
there are definitely some plans to, I want to continue this.
We've really enjoyed this project, and
It's been a lot of fun.
I think
Like,
it'd be
helium-
So why C# instead of Java or C++?
C# in particular, I think is, I've always been kind of partial to C#. That's pretty much because of my dad's influence. He's been working with coding for pretty much all his life, and he's always stayed to C#, and he's also our mentor for this program. And I really liked what I've worked with C# and C++, and just the new compatibilities with the tools that I discovered in there. It's pretty amazing with the new one.
One thing that, when the electron gets in, passes through the proton, that seems really odd from the physical, from the physics thing. And I'm just sort of wondering what your explanation of that is.
Well, that goes to the quantum model, which suggests that an electron acts as both a particle as well as a wave. So if it was just energy, then it would be able to pass through a solid object,
And
like a proton.
And it doesn't happen very often. It's happened like once or twice in our code whenever we run it, and it just happened particularly this time. And but as the probability curve, as the probability curve shows, it does actually go to 0, and we verified that one on like 3 different sites.
Probably doesn't
Yes.
go through the proton.
Yeah,
Probably.
yeah.
But we don't know enough about electrons. Nobody does to know exactly what's going on in there.
Most accepted theories is without those.
Yeah, exactly.
Yes.
Can you explain how you drew the pictures of the 2P and the 3D?
Oh,
Because they didn't mention anything about that.
oh, those ones we just got out of the
Internet.
textbook. The textbooks have just previous scientists have drawn those out and what they look like.
So you guys, that's where you did the majority of your research? Or just describe?
Well, we had a lot of outside help with that. 2 teachers in particular at our school helped us, and that was Ms. Jones, our chemistry teacher, and Mr. Suding, our physics teacher. And they both lent us huge books about quantum mechanics, and after looking up a bunch of stuff, we realized that we can't really grasp a lot of the difficulties in that theory, but we got the basics of that in the electron cloud and stuff, but pretty much it was from outside help that we got our...
We really started with just a basic circle and then something flying around this circle. Then we started, gathering our information and, slowly adding it in so that it started acting more and more like an atom.
Could you put in something to jump to those higher energy levels?
I could actually pretty easily. We got rid of that. We actually had that at one point where the random number generator replaced our probability curve. That was actually before the probability curve was in existence, but we actually had it jumping. And it is actually decently easy to implement. We decided not to in this case because we just wanted to show a simple...
But I'm thinking of a key that would say... jump
Yes,
to the next.
that is...
Not random.
No, not randomly, but yes, we could definitely implement a key there that would make it jump and then fall back. But the thing with that is when it jumps, it almost instantly falls back just to release energy and stuff. But
It's something we can pursue in the future because I've enjoyed this program. Yes.
Is a relation to the orbitals. The one is the other one that you were showing before. So, when you in quantum mechanics.